Hey everybody, my name is Alex Merced, and welcome to another Gnarly Data Waves presented to you by Dremio. And today we're at episode 46. Oh, how the time has passed. And we have a really exciting episode getting started with Dremio. Before we get started, I just want to remind everybody that Subsurface is right around the corner, May 2nd and May 3rd, which will be held live in New York and virtual online, so you can see it wherever you're at. Get registered today over there at dremio.com/subsurface. It's going to be lots of great talks about data lakehouses, table formats, implementation patterns, all sorts of really great stuff. Make sure you're there. But with that, no further ado, let's get started with our feature presentation. With getting started with Dremio, presenter today will be Reed Maloney, CMO at Dremio, and I will join in a little bit later to present to you a cool little demo. But with that, uh, Reed, the stage is yours.
Great, thanks, Alex. One of the things, one of the call outs too, we'll talk a little bit about today for Subsurface is the number of sessions we'll have around Iceberg as well. It's been a topic, obviously, you know a lot about, Alex, with your work on the O'Reilly book and how much you've done around the definitive guide around Iceberg and sort of what's really happening there. And that'll be an exciting part of that overall event. One of the things we want to talk about is I'm going to cover a real quick overview. Like we're going to do maybe 15 minutes or so of presentation, and then we're going to switch over to demo. And we're big on that here. We want to show you like everything we're going to talk about is real, but we like to run these sessions every couple of months because we continually have new customers come in. And as customers come in and they talk about their use cases, we have more use cases to develop. And so we like to come back to the market and say, hey, like, what is Dremio and how is it being used and why is it being used? And so every quarter or so, we really update this episode. So, and same thing with the demo. So Alex got some new stuff in the demo today that we're excited to showcase. So Dremio, what are we? We're a unified lakehouse platform, self-service analytics. We'll talk more about how that comes together and what that could mean for your organizations or your teams that you're working on. But ultimately, unification, we're working across all of your data, wherever it is, any of the major types of platforms that you're storing it in. It could be on-prem, it could be in the cloud, it could be both. Bringing that together for your organization. And then we're continuously working on making it easier and easier and easier to use for both engineers and analysts so that you can do more with the platform and bring more data into all the different lines of business and departments that either you're in or that your teams are supporting. So how do we get here? It's sort of like we've been doing these different changes and steps in terms of data platforms for a while. We start to see, if you see there's 5 different items on the slide, we'll talk through them real quick. I've seen a lot written to say this, we're actually in the 6th group now in terms of data platforms, but how did we get here? We got here from enterprise data warehouses at the start, right? We start saying, look, we have all this data. We want to get insights out of it. We want to start driving our businesses using this data and moving forward. And that was really with Teradata and Oracle, Netezza, et cetera. But we couldn't scale. And so that led really to the movement around Hadoop and big data. And what did we find there? It was too slow, and then it got really costly to manage. And so with the cloud data warehouses, they were able to separate compute and storage, and we started getting that scale, and we started getting speed with that, but we sort of ended up with Teradata in the cloud. So now we have these proprietary, really expensive systems that scale a lot better than they used to, but ultimately we start to end up in a relatively similar set of problems that cause like why people are continuing to move from Teradata is now also the same reason why people are starting to move from Snowflake, because we basically have Teradata in the cloud. We'll talk a little bit more about some specifics that we have as people move to open architectures, whether they're using any type of open data or whether they're using an open table format like datalake or Iceberg, moving on to the data lakehouse, where they then have the best of breeds in terms of componentry. They're able to have more of a distributed platform in terms of providing that to the customer. And that's really been, driving the rise. And so Iceberg and these table formats have been really allowing, now you can do full-on warehousing on the lake. And then really in the next instantiation that's getting pushed here is all of the advancements in AI are getting brought into the lakehouse. And something we'll talk a bit about later that's unique to Dremio is that you can start to manage your data as code. So you can have your main data asset, just think about it as a data product. You can branch that as you add more data in. You can then check it, make sure it's right before you merge it back. And you're doing all of that without actually creating physical copies of the data. And so doing that on the engineering side and then enabling self-service from a platform perspective on the analyst side is really what gets us into the more of the data mesh concepts, where we're enabling both governance and quality, but we're also enabling speed and agility. And so what we've seen because of this change, this movement in the market, is we went out and did a survey to just 500 different organizations. These are not Dremio organizations, and we have this on our website. It's our 2024 data and analytics trends and predictions. We've done some events with customers around this. We also have a white paper. I'm just highlighting one stat here, which is 70% believe that they'll be running 70% of analytics will be run in a lakehouse in the next 3 years. And so I put out a blog recently saying, I think this is the year actually where the lakehouse crosses the warehouse, that 50% mark, in terms of that we'll see the majority of analytics start being run in the lakehouse by the end of the year. And that's happened so quickly. And it's really due to the value that the lakehouses are providing over what the current solutions are from a data platform perspective. And this is one of them, which is a lot of architecture still look like this. You have a whole range of sources. You have a bunch of ETL pipelines that you're moving data into the lake. You then have a whole nother set of transformations that you're doing as you move the data into a warehouse. And then you're also still typically doing extracts into different client tools like Tableau. And so any of these items go and they break, you then go back and you have a problem and you got to go troubleshoot it. And that's really preventing a lot of teams from finding the data that they need, creating the views that they want to be able to query and then move quickly. It also adds a ton of cost. So it's expensive to manage. You have all these systems. And then that also makes it hard to govern. And so lakehouses have really been helping here, because you really just remove the warehouse part here, okay, where you're able to start shifting the data consumer closer to the product, which we think about as shifting left in terms of the amount of ETL that you need to do. And then if you have less hops, you're getting closer to be self-service and helping the business move faster. But they're not totally sufficient in terms of driving self-service. You need to be able to remove the extracts. You need to be able to shift even closer over. And to do that, you really need 3 things. You need an intelligent query engine, which is something that Dremio offers that nobody else does. And we'll talk about what that means a little bit later. You need an intuitive self-service experience, both for the engineers and the analysts. And then you need a set of next generation data ops capabilities. And I'll talk more about that too. I just alluded to it. And Alex has a great demo here in terms of what that starts to look like as you start treating your data as code and you're dealing with products that you're then branching, checking, and merging in terms of the data management. You're going to get a cleaner result. It's going to be a lot easier to manage. And so this is what Dremio looks like today. We have 3 main capabilities. We have the unified analytics capability. This is where you're able to look across all of your data sources. You're able to find the data and create the views that you need. We have a universal semantic layer, and then you're able to govern across all of those different sources as well. We have a SQL query engine. It's excellent on price performance. So we make that a huge pillar for us. And then we have this technology that we're going to talk about that's related to our intelligent query engine called Reflections. And you'll see that as Reflections Acceleration. And then in Lakehouse Management, we have an Iceberg native catalog. We've talked about Git for data, and we do some things specific to automatic data optimization. And then we have 2 options. You can run self-managed, or you can run in the cloud, or you can do both, which really provides a very flexible architecture. And here's the connections: ODBC, Aeroflight, REST, through all the different client tools that you may want to connect into Dremio. So what makes Dremio different? There's a lot of different providers out there that you could look at to say, hey, is this going to be a component of my data platform? And if so, where does that fit? Um, Overall, like we're going to deliver the best in class TCO as your SQL engine in your platform. We do a set of other work I just talked about, such as you won't need to make copies of your data. You won't need to set up separate environments. That's something that Git4Data helps you with as well. All of this contributes to being able to operate your data platform very efficiently, as well as having best-in-class price performance. The next is fastest time to insight. This is what we talk about in terms of shifting left. We're making it much easier for analysts to go and create the views they need in a governed manner and query them, while the engineers can go and help to optimize and ensure that the platform is still running very fast, but also running in a very cost-effective manner. And you don't bottleneck on one versus the other. And I'll have a slide on that later. That's related to the intelligent query engine and reflections that we talked about. And then we have ease of use through self-service data. This is an intuitive UI with a universal semantic layer. And then we have a flexible and open architecture. Again, with open data and open table formats like Apache Iceberg, and then also being able to run in the cloud or on-prem. It gives you the most flexibility in how to set up your data platform. And so you're not locked into proprietary formats where we're just, again, repeating, where we now have Teradata in the cloud with Snowflake. And we've seen, I'll show you later some of the savings that customers have from moving both to a more flexible architecture, but then also saving a lot of money while they're doing that. So here's some really common use cases for us. We see customers that are modernizing from Hadoop. So they have Hadoop still on-prem, and then they're migrating that to object storage, and then using Dremio with the object storage to do their warehousing on the lake. So lakehouse to take over from what they were doing with Hadoop. We have unified data access for analytics and AI, again, bridging across multiple data sources and eliminating data silos. Warehouse to lakehouse. So we're seeing more and more of this, where if you have a traditional warehouse and you're saying, look, I need to reduce the costs. I want to have scale, flexibility, reduce costs. You're starting to see that move over into Dremio. Data virtualization. Again, this goes to helping the business move much faster. And so based on our technology, we're able to usually in the past, data virtualization really slowed your system down. That doesn't happen with Dremio. And so you can have really fast performance while still allowing the business to create their virtualized data marts and views to help them move very quickly. Data mesh, we support all the concepts around data mesh very well, including data products. As I said, we also have governance built into the platform as well. And then lakehouse data ops. And this will relate to how you're moving data into your lake, how you're building and managing your data products. And this is something that Alex will demo later. Okay, thanks for the poll. We're going to get into one of the ones we talked about where we're seeing warehouse to lakehouse, specifically with Snowmelt, with Snowflake moving over to Dremio. But we have a question on the poll right now, which is like, what use case are you looking at? So this is what we're seeing. We'll give a moment for people to vote in terms of what you're looking at. Right now, you may not know. That's fine too. That's sort of the purpose of the getting started session, is help you just explore where we typically will fit into your overall data platform or data architecture, or how you're trying to support your business. All right, so we have a lot around unified data access for analytics and AI. Again, very common that will go through, and warehouse to lakehouse and data mesh. So excellent. Those are real top ones. And then we will be talking about lakehouse data ops. So if that's not what you were thinking coming in, that's totally fine. But we'll show you what that starts to look like now when you're starting to manage your data as code and think more in the line of data products overall. Okay, so in terms of this is going to be focused on everyone in the poll that just talked about, hey, we're looking at warehouse to lakehouse. Or if you were looking at us from a unified analytics perspective, you may not know what we can do on the right side of the house. So instead of just reading from multiple sources, now it's actually just writing data into the lake, often using a combination of like DBT as well as our SQL engine, and what that looks like. So as that happens, we call this is really our snow melt initiative. So this is one of our Fortune 10 customers, and this is specific to one of their departments. And so when we work with Snowflake, it's really, it's often not just us or Snowflake, and I'll show you the architecture. It's typically us and Snowflake as customers start to cost optimize their platform, or they've been sitting there with a bunch of overages. Snowflake's getting really expensive. How are you going to be able to manage and do cost control? You'll often use both of us. And so we have a reference architecture for that based on what we're seeing from quite a few customers and an increasing number of customers here. So in this one, this is just one department. They saved $3 million. It was a 75% savings. And so that was a huge change. One of the other ones that was because we support BI directly on the lake without pre-computation and without extracts. This is the reflections technology that I'll have a slide on later. They went from weeks and days in terms of making changes to the reports that they had in Tableau to be able to just do it in minutes or seconds. And when we talk about self-service, that's what we mean, is there's these huge changes. Specifically, this one is 20x faster in terms of their specific timelines for the customer. And this isn't isolated. Just so you know, we have a TCO report with Dremio and Snowflake. These are customer examples, but we also did one based on a TCPDS benchmark and also some other customers we have in sort of aggregating groups. And we have that paper online as well. So you can go look that out, see specifically how we did the evaluation. You can see each item. You can actually go and replicate the evaluation and do it yourself. Here's one customer who did it with their workloads versus TCPDS when they were looking. And so when they did this comparison, we were 91% lower for them in terms of what they saw with Dremio versus Snowflake. And this is a global leader in manufacturing of commercial vehicles. So often this is what we'll see from a combined architecture. So customers will cost optimize with us. They'll also use us, as you saw a lot of people that are here, they're looking to eliminate data silos and do unified analytics. So you can do that as well. And then you're also really setting yourself up with an open architecture. So as you continue to move and look at, hey, how do I ensure that I have control over my platform and I'm not beholden to one proprietary system? I can continually evaluate across this entire ecosystem of technologies that make up my platform. This is a great way to get there. And so this is often the reference that we'll see as customers are using both Dremio and Snowflake together. A couple examples on Hadoop. So if we didn't see a lot of this in terms of the group that's here today, but you'll see similar metrics from other types of migrations when you're moving to Dremio. So in this case, TransUnion had a 10x gain, NetApp a 22x gain, and NCR had a 30x gain when they were moving from Hadoop over to Dremio. And on average, this self-funds in about 3 months. So in terms of saying, hey, we're moving this and we're going to go to an architecture where we're going from HDFS to object store, it's about 3 months. You're able to pay for the project itself in about 3 months. And then the savings from there just accelerate. Again, if you're of 30x price performance, you can think about the infrastructure difference that you need and how much savings that brings to the organization, and then how much that simplifies management overall. So this is often what we see as people initially start the movement, and I'll show a couple of specific customer examples, is they'll run Hadoop and object storage, and they'll put us over the top, and we'll be querying both, and you'll see immediate benefits from that. And then over time, they continually move all of the data into object storage, and it can be totally transparent to the business user. So the business user is just writing queries, and they're just over time getting faster and faster and faster and faster performance. And all of the data consumers are sitting there with their tools that are just connecting into Dremio, and this part of the movement can be transparent to them as that process takes place. Here's an example specifically from NetApp. So NetApp is not only a partner, which will show the architecture on, they're also a customer. So they moved from Cloudera to a combination of NetApp and Dremio, and this is what they looked like beforehand, with 7 petabytes of data and 4,000 cores. Is they moved over, and so they used their products called Storage Grid, and they moved over. When they consolidated, moved over, and they now have 3 petabytes of data in their ActiveIQ data lake, with about 9,000 tables that they're running. And so this is how they've set up their overall architecture to support their business. And some of the differences they saw was they had 22 times faster query time. They had a greater than 60% reduction in TCO, and so or reduction in compute. And their TCO in the first year, this is just the first year, was already 30%, even as they were going through the migration. And so this typically will end up, around the 70% to 80% mark, almost, 8 to 10x less expensive. And then one of our other partners in this space is Vast Data. And so Vast Data supports, is also involved when we see customers migrating from Hadoop, or when they're looking at platforms that are going to run multi-cloud, hybrid, or on premises. Okay, so these 2 pieces I want to talk about were reflections. This is a technology that only Dremio has, and it helps support an element of what reflections does is it's part of our query engine, and we're able to rewrite SQL on the fly. So what'll happen is we have the data sources come in, and purple in this case, these are physical tables. Okay, sorry, physical data, and green is where these are virtualized views of the data. And this little lightning bolt is a reflection. I'll explain what that is. So if the data comes in, you have voter data in this case, and you have voter survey data, and you may go and create a view off of that that's enriched voter data. And then you may want to have a specific view that's Ohio and Illinois. Well, as you're querying that data, you're doing schema on read, and then you're eventually hitting back into these tables, and then that can create a performance problem. And so what we do is we will recommend and tell you, hey, look, we think you should have a reflection on this view. And we will then go and we'll help create that, and then we'll help maintain that to help with performance. What's really secret here is that, or what's really unique here, I should say, is that the queries that were written towards Ohio voters, for example, a dashboard based on that, never has to change to reflect the materialization of that view that's delivered by reflections. Okay, the SQL will actually be rewritten on the fly by the query engine. And that's what I mean when I talk about the query engine being intelligent. It will recognize the data, and then it will the reflection, and it will then rewrite the SQL to take advantage of it. And so you get both this the setup where the users can go create views and put dashboards on views and move really quickly, and then you can have the engineers working with reflections to help manage the system performance and the cost of the system as they go and are running dashboards directly on those views. So this is a unique item for Dremio that only a unique item that only Dremio has. And one of the next ones, and again, Alex is going to show this in the demo we talked about, is Git inspired data versioning. It's related to next gen data ops. So what will happen is you have a main branch of data. We'll have to think about that as a data product. And you're going to add, in this case, data to that data product. So you're going to branch it. This is not a physical copy. It's a pointer back to the actual data. And you're going to then ingest the data and then run quality checks against that data. If the quality checks pass, you then merge that data and you have the next version of your data. So this really helps to ensure you have clear data ownership, clean data coming in. And if something does go wrong, it's now much simpler and faster to troubleshoot where the problem happened. And this gets us into a much more automated way to deliver data to the business, which is where we're saying this is related to next-gen data ops. And then on the other side, from the data science perspective, from an experimentation, I can now just create a branch of that data to experiment. Again, it's not a physical copy. I can then work on that and do feature engineering. It's probably one of the main items is to start working on the feature engineering, bring other data in to that branch. And then as I have features, I can bring those back into my data lake and store them, or I can go and just shut down the branch if I didn't discover or learn what I wanted to do. So before we move over to the demo, just a quick summary. What we see from customers is they're trying to improve data adoption in their organization. They're trying to move a lot faster, so they're reducing their mean time to insight, and they're trying to lower their costs at the same time that they're trying to deliver a lot more to their business from an adoption standpoint, which we think about as shifting left. All of these benefits come from shifting left. And to do that, you need an intelligent query engine. You have to have an intuitive self-service experience, and you have to have these next-gen data ops capabilities, which is specifically what we're working on at Dremio. It's why we're in business. It's why we exist. And this is why customers are continually looking at and choosing Dremio to be a core part of their data platform. So with that, Alex, I'm going to turn it over to you to show Dremio, so people can get started and use these capabilities for themselves or try them out for free.
Hey everybody, welcome to this demonstration of Dremio, the unified lakehouse analytics platform. A platform that aims to make data lakehouse architecture easy, open, and fast by providing you with unified analytics to combine all your data sources, such as object storage or on-prem data lakes and other data sources in your long tail of analytical sources such as relational databases, NoSQL databases, data warehouses, and more, and being able to combine them all through Dremio's universal semantic layer, where you can govern it and make sure you maintain top-level security. But not only can you curate the data, but you can query that data with a SQL query engine that has top price performance, allowing you to use unique features to Dremio, such as reflections to accelerate those queries, allows you to federate those queries, and again, allows you to operate across multiple clouds and hybrid cloud and on-prem environments. But oftentimes, the center of your analytical world will be your data lake as you build a data lakehouse. So being able to manage that lakehouse so that way it just works is a big part of what Dremio brings to the table with its lakehouse management features, providing you a modern data catalog with Git for data features along with automatic table optimization. So that way those tables are always crisp, always fast when they're queried. And again, this platform can be brought to you either through a self-managed Kubernetes deployment or through a cloud-managed SaaS deployment. So again, Dremio allows you to shift left, so allows you to kind of move more and more of your workloads from the extra storage cost, the extra compute cost, the extra egress cost of having to work more in a data warehouse and be able to, again, shift left so that way you're doing more of your workloads on the data lake. Okay, so that way Dremio is able to make the center of your analytical world your data lake, because you'll be able to connect your data sources directly to Dremio and then deliver that directly to your analysts, data scientists, etc. Because Dremio provides you that intuitive self-service experience, that intelligent and powerful query engine, and those next generation data ops capabilities with its integrated catalog, those Git-like features, table optimization, and more. So now let's begin with the demonstration. Hello and welcome to this demonstration of the Dremio Unified Analytics Platform. In this demonstration, we're going to assume that I'm a data engineer and I'm getting different types of data requests from data analysts and data scientists on basically curating our data platform. So you can see here several different requests that I am receiving in my backlog that I would like to, well, kind of see in that completed column. So what we're going to do is we're going to go through each of these one by one and kind of demonstrate the powers of the Dremio Cloud platform in making life easier for your data engineers, your data analysts, and data scientists as we go. So basically what's going to happen is that first let's go over to our Dremio platform. So when you're taking a look at the Dremio platform, bottom line is you're going to have your default catalog, which is generally where you're going to curate your semantic layer right over here. Here you can have any additional catalogs, any connections to object storage, databases, data warehouses, all curated, which you can add easily by just clicking add source to see the variety of different sources that you can connect to. Okay, but we're going to be working today is I'm going to be curating some work out of here in this catalog. In our Arctic catalog, we have our demos catalog. And in here, I'm going to have our Feb get started. And here we're going to be doing some work. And as you can see here, what I have is a departments and employees table. Okay, that we're going to want to work with, but we have some requests regarding this raw data. So again, this is the raw data. Whenever you see purple tables, those are raw data tables, not, as we'll see later on, views, which are not copies. They are just logical views on that data. So you're reducing your total storage input by not making copies in Dremio's no copy architecture. So the first request that I'm getting is to create a view of employees and the departments they work for. Okay. So probably the first step I'm going to want to do in that, so if I take a look at this, I've broken it down into several steps that I'm going to do. I'm going to create a view joining the employees and departments because I need to kind of have that all sort of in one view. But at the end of the day, after I create that, I'm going to create another view that only shows me the employee and their department. So how would I go about that? Well, fortunately, I do a cool feature of Dremio is that you're able to save scripts with SQL. So in here I have a script that already kind of does the join part of this. Okay, so that I have right here. Okay, and what I can do is I can just set this to the right context to where that table is. Okay, so I'm going to sit here and say, hey, Feb, get started. Okay, and what's going to do is it's going to create a view called raw department employees that is a join of those two tables. Okay, so now I can just run that query. Okay, and a couple things to notice is I notice how it gets this tab, so you can actually run multiple queries in the same window, and each one will get its own tab. Two, I can actually have multiple query engine tabs, so that we can actually have completely different workspaces working on different queries and different data sets at the same time, making this a really robust and easy to use SQL editor. But as you can see there, I've created the view. Okay, so now what I can do is I'm going to head back over here and take a look at demos 2024. Feb get started. Okay, and see now I've created a view. So notice how the icon is green. This means this is a view. So this is not a copy of the data. So technically the only physical data that I have stored currently are these two data sets right here. And this just allows me to provide a view that I can then grant access to my data analyst who needs this data. Okay, but really they don't want this. They want just the name and the department. Okay, but just to show you that when I run a query on this, I get the joined data. But really that's not what the analyst wanted. They wanted, just first name, last name, and department, really just the department name. So if I look over here at the columns, that's going to be this name column right here. Okay, and we just rename that as department. So now what I'm going to do is I'm going to run that query just to make sure that it gives me the output that I expect. Okay, and I see there we go, 3 columns. So that looks like the view that my analyst requested. So what I can do now is I can just click Save As View, and this can also be done with SQL, which again, SQL can then be sent not only through the Dremio UI, but through JDBC ODBC, through Dremio's REST API, and Apache Aerofly, allowing a lot of the aspects of Dremio to be automated by external code if you wish. So now I can save this view. Okay, and again, I can save it where I want it. So here in the demos folder, here in 2024, under Feb Get Started. Okay, and we'll call this like raw. We'll call this name and department. Okay, I will save that. Okay, and then that will complete that. So now I can go back to over here to kind of see the results. So if I head over back to demos, okay, 2024, Feb Get Started. Okay, and then we see the name and department view. And again, I can then grant access to that user. So I can click over here under settings, okay, and see where it says privileges. I can then grant this access to this view to a user of my choice, and then actually choose their level of access to that view or to that table. So I get really fine-grained access. On top of it, you have built-in column and row access rules, so you can actually do very, very granular access to make sure that your users only see what they're supposed to have access to. Okay, cool. So we created that view. Okay, so we've satisfied this ticket. I've created the view I created the join, and we created the view with name and department. Wonderful. Okay, so that means this ticket, which we have been working on, is now completed. So now let's bring over the next ticket. Okay, so in this next ticket, what we're going to do is it turns out that analyst wasn't happy with the view we created. They didn't want a separate first name and last name field. They really wanted a single field. So now they filed a ticket requesting that field. Now, normally using other systems, this would require me, the data engineer, to go back and change the creation of the view in order for me to be able to provide this for them. But luckily with Dremio is very self-service. So the analyst can actually deliver this for themselves. So if I'm the analyst, I can just log into my account where I have access to this name and department view. Okay, and then I can then make the changes necessary to get the view that I really wanted. Okay, so I can say, hey, I want first name. Okay, and actually, to make this even easier, what I can do is I can use the text to SQL feature over here. So what I can do, so I grab this field here, and I'm just going to go grab the data set that I want to do this on. Okay, so that's going to be under demos 2024. Feb get started. Here is the name and department table or view. I put that right there and say, hey, I want the first name and last name field to be a single field called full name. And in this view, also include the department field. Okay, so I can click generate, and it's going to generate the SQL for me to do that. And let's see, here I have exactly that. So now I can copy this SQL. Okay, or I can just insert it. Okay, and see, it'll do that for me. I like to always kind of get rid of some of this extra white space there. But yeah, so then I can run this to see if this gives me the result that I want. Okay, name, department. Oh, okay, so I have to set the context because see right now, just to give see it's saying name department. So right now, since I have no context set, it's going to expect the fully qualified name. So I have to give like demos.2024.feb get started. I could do that, but the beauty of the Dremio engine, to make life a lot easier, I can click here on the context, and I can actually just set the context to exactly where I expect this table to be, which is right here. And now that that's set, and notice these errors are pretty self-explanatory. So I can see, hey, it's not finding where it's looking for it, and now I can kind of go back and adjust, and then run my query again. Okay, so good errors makes for good troubleshooting. So now I see that I have the results that I want. That's the view that I want. So I, as the data analyst, can now just go save that as a view for myself. Okay, and say, hey, I want that particular view, and say, full name, department. Save that back in that same folder. So demos, Feb 2024. Feb get started. Okay. And hit save. Okay. And now that view is going to be available in that folder. So if I go over there, and there it is, full name department. So yay, I have fixed it. Okay, so there we go. I can say, hey, you know what? I have made a full name field, and now, and again, this time the data engineer didn't have to do it. That's the beauty of this aspect of it, the self-service aspect of Dremio, where there's going to be a lot of times where the data analyst or data scientist will just be able to kind of handle many of these requests themselves with the data that you've given them access to, instead of constantly having to go back and wait weeks sometimes for data requests to the data engineer, who already has a huge backlog of requests coming in. So the next thing we want to do is that we want to update that original view, because they realize that they would also like the budget column in that view. So that is going to require the data engineer. Okay, so first let me just move this over to completed, move this over here. And essentially what we're going to do is we're going to update the view that we already created, okay, and make sure that it includes that view. Okay, so let me just close out some of these extra tabs. So what I'm going to do is I want to update this name department view. Okay, so I'm going to click on this pen, so that way I'm in sort of edit mode. Okay, so see here it's showing me the original SQL. Okay, instead of just showing me the view namespace. So this is going to allow me to update that view. Okay, so now I can go in here and just say, hey, I want to add, budget. Okay, and then what I can do is I can just pop this out just so that way I can make sure I can see the any information that I want here, because usually I can see the different columns here. Okay, but let's just see here if I type in budget. Okay, and let's just run the query, see if it gets me the result that I wanted. Okay, and I see here, first name, last name, name, department is showing up as a number. Okay, so the reason is, same mistake I've done before, is that this should be name as department, and then I need to add another comma to here for budget. So you see, that's why I run the query first. I can just confirm that I did it quickly, do a quick visual validation, and then I can go back and correct, doing a lot of this stuff a lot easier versus finding out that you made a mistake way down the line. And there we go. Name as department. Although I see I have a name and department field, I should only be seeing one. So I'm examining a first name, last name. Oh, I see I have name twice. So let me go take out name there. Okay, and let's run that again. And there we go. Okay, so there's the view that I want, and now I can just click Save View. Okay, now I've just made a new save to the view. And again, these views are not copies, so nowhere have I duplicated data up to this point. Okay, but now I'm creating assets that people can view to see the data as they need to see it, and only the data they need to see. But another really cool thing about Dremio is that since I'm using the Dremio catalogs, okay, what I can do, currently called Arctic catalogs, okay, I can go into this catalog and I can actually see all the commits. So if I go over here, every change is a commit to the catalog. So I can see, hey, look, there was that alter view statement done 30 seconds ago. That was me updating the view. Okay, and I can see when I created these views, and I can see, hey, who did it. This gives me a very high level of observability into what's going on in my catalog, what changes are being made, who is making those changes. But it also gives me the ability to roll back to any of these commits. So just like Git, if something goes wrong, I can roll back to a commit where things were good. I can create tags, so that way I can tag particular commits that I want to be able to easily replicate. So I can say, hey, I want to tag I want to be able to scan or do a query at the catalog as it was at that point in time. Okay, and I can create branches to like isolate work, which we'll be showing you shortly. Okay, but going back over here, we did that. We updated the view to include the budget. Wonderful. And next, what we're going to do is we're going to be ingesting some new data into the employees and department table. Okay, so actually first let me move this to completed. Okay, and then we're going to move this over here to show you ingesting new data into the employees and department table. So what steps am I going to take? Well, one thing I'm going to do is I'm going to take advantage of those Git-like features, because I don't want to accidentally ingest the data and then there's a mistake with it, and now I'm having to pluck out the bad records, do backfilling, all that tedious work, and also affect production queries. What I'm going to want to do is isolate that work from my production branch, the main branch, and get it done. Okay, so I'm going to create a branch to isolate the changes, do all the work on that branch. Then I would theoretically validate changes, whether I run any queries that will just double check to make sure that there's nothing wrong. And then once all those queries have ran successfully and I'm happy with my results and I'm happy with the changes, I can then merge those changes in there. And again, while I'm going to do all this in the UI, again, this is all done through SQL. And like anything that's SQL and Dremio, it could be automated using external programming scripts that connect via JDBC, ODBC, our REST API, or via Apache Arrow Flight. Okay, so it's all very, very flexible. So now let's go do it. Okay, so in this case, let me go back to our query engine. And basically, I have a script for just this particular purpose. Okay, so right here. So here's the script. Let me just make sure I set the context to the folder we're working out of today, which is this feb get started folder. Okay, so there's my context set. So basically, if I were to walk through this, as you see here, Okay, I'm going to first query the tables as they are, just to show you that, hey, let's just see how many records are in the table before we do anything. Okay, then we're going to create and switch to another branch, which you can see is very simple SQL. Okay, so taking advantage of this feature is actually pretty easy. I will then ingest the new records into the respective tables. We'll then query the count of the table, so you can see that on this new branch, okay, there is going to be the new data. And on that note, I want to make sure that we use a unique new branch name. So I'm going to call this Feb19. Okay, and I'm just going to change that everywhere in the script where we refer to the branch, so that way I'm not using a branch that already exists. The idea is you create a new branch to isolate those particular set of changes. Okay, so again, I'm creating the branch and then switching to that branch, ingesting the data. Then we're going to count the record so you can see that the data has changed. Then we're going to switch back to the main branch, query the main branch so you can see that the main branch has not changed, so that the count should still be the same. Then we will merge the changes, query the main branch again so you can see that now the counts reflect the new data. Okay, and so theoretically, before we do that merge, that's when you would do your validations, whether you're using like DBT, Monte Carlo, Great Expectations, whatever your preferred way of validating your data is, or using sort of your own queries against like your own business rules tables or constraint tables that you're checking. Okay, so with that, I'm going to go right over here and we're going to run this query and let this run. And again, so notice how many queries I have just running right here in this one editor. Okay, so again, I have that editor in this tab, and then again, each query down here is getting its own tab. Okay, making it really easy to get a lot of work done very quickly. And I can actually start already seeing the results of queries that have completed. So I can see that original query that queries the tables, that we see a count of 5 in the departments table and a count of 10 in the employees table. So that's before we make any changes. So I go to query 3. Okay, I create a branch, so I can confirm that the branch has been created. Okay, I can then see query number 4. Okay, that we have switched over to that Feb19 branch. Okay, then I can see that we're now from that branch, I've inserted 5 records into departments, and notice how it highlights the query that I'm referring to as I do it. So if I click on query 6, see it's going to go highlight over here because that's the query that this particular tab corresponds to. So here I injected another 5 records into employees. Okay, so now when I query the ETL branch, I'll see that now departments has 10 records versus the 5 it had before, and employees has 15 records versus the 10 that it had before. Okay, now I'm going to switch back to the main branch. Okay, so right here we switched back to the main branch, so that switches our context. And then what I'm doing is I'm going to query tables on the main branch before the merge. So we see, notice that we have still 5 records. So again, my main branch, my production data has not changed. It's still only 5 records and only going to be 10 records for the employees table. So that's the beauty of this. We've isolated the changes. The changes are not being hit in our production queries. But once I do the merge, okay, and we can see here that the merge has been confirmed, I can then see that now when I query the main branch, I do see the additional records, 10 and 15. Okay, so I can isolate my changes. I can create branches for experimental purposes. There's a lot of use cases for this particular form. It can be very, very powerful. We've seen customers who've used a pattern of basically creating a branch for every day. So at the beginning of each day, they create a branch. Then all the ingestion work throughout the day is done on that branch, validated at the end of the day, and then merge into their mainline production data set at the end if all validations have passed and the data has been cleaned up. Okay, making it really easy for them to assure that that mainline production branch is always in top quality. So we've completed that. So again, we created that branch, we ingested the data, validations can occur at that point, and then we merge the data back in. Easy peasy. Okay, now one last ticket I get is I have a ticket from a data analyst, data user who is building a BI dashboard. And the problem is they need to improve the performance of the BI dashboard on that weather data. Okay, on weather data. So let's take a look. Okay, so if I go take a look for that weather data set, should be here again in our trusty folder, 2024, Feb get started. Okay, and we see this weather data set. So theoretically, we have a user who's building a BI dashboard on this. Now, usually BI dashboards are usually the result of a lot of aggregations, so using group by statements, sum, counts, all these kinds of things. So what I want to do is that I want to make this faster. So Dremio has a very unique feature called reflections, and I can, by clicking here where I say edit dataset, it's going to take me to this screen where again I can see the original table if it was the original query if it was a view, but I can also see the section called reflections. Okay, and now notice there's two types of reflections. There are raw reflections and aggregate reflections. So raw reflections essentially replaces the need for materialized views. Okay, so anytime you need to speed up the query on raw rows of the table, okay, you can just use raw reflections instead. Okay, you would just turn it on. Okay, so I'll just quickly show you. So I can turn on raw reflections, and then I can even tailor these raw reflections to, only materialize certain columns, to sort based on certain columns or partition based on certain columns, and I can actually create multiple reflections. So typically what you do is you'd create multiple materialized views for different query patterns, and users would have to kind of know which one to query. Here, you create the reflections and Dremio does the figuring out for you. It'll say, okay, hey, I have these 5 reflections. For your query, this one's going to make the most sense for making to complete your query the fastest on this particular table. So instead of taking one table and turning it into 5 additional namespaces, you just have one namespace. Users are just going to notice that their queries are faster. Okay. So now if I go back to reflections, okay, then we have our aggregate reflections. This is going to be more important for like BI dashboards. So again, in this situation, we have a user who's building a BI dashboard on the weather column. So theoretically, what I can do is I can turn on aggregation reflections, choose which dimensions, okay, they are optimizing for, which measures they're optimizing for. Okay, so maybe where they're measuring like precipitation and snowfall based on station and name. Okay, so then what I can do is, again, those are the types of queries they're doing on their dashboard. And then what I'm going to do is I'll hit save. And what's going to do, it's going to create a materialization, a pre-computed version of those results. But instead, the user doesn't have to really worry about this. They're just going to notice that their BI dashboard is just much faster. Sub-second queries, okay, because all those results are pre-computed. Okay, but Dremio is going to handle, again, the swapping out of knowing when to use these materializations, and 2, updating these materializations on a cadence. Okay, so that you can also manually trigger via REST API and soon SQL. So bottom line, it gives you a really easy way for me to accelerate, because oftentimes building a BI cube or extract would be much harder than just flipping a switch like I just did. On top of it would require a lot more maintenance work, manual maintenance work on behalf of the data engineer. So now I'm getting those same benefits at the flip of a switch. And same thing for like materialized views with raw reflections. Okay, and all these things make the Dremio platform much, much easier. And again, just a couple of the things I'd like to point out is that when you're using Dremio Cloud, again, you also get this jobs page that makes it really easy to monitor all the jobs coming into your Dremio cluster to see sort of who's running what queries and how are they performing and seeing their breakdowns. On top of that, you have this engine section where you can control the compute that you make available to your users. So you can have different engines of different sizes, and you can use engine routing to make sure that you're routing workloads to the engines that that you want. So for example, I might have high priority workloads and that I want to make sure go to particular engines that will execute them faster, and I maybe have lower priority workloads that don't need to use the expensive compute. Okay, so I have very flexible control to make sure that I'm scaling and managing my workloads in a way that's going to get me the performance that I need without breaking the buck. Okay, because the engines can scale up and scale down based on the rules that you set. So you have a lot of flexibility as a data engineer to build what you need, but it's also easy to do and really kind of unifies all your data, because again, you're connecting all your data across databases, data lakes, and data warehouses. So hopefully you guys enjoyed this tour of the Dremio Unified Lakehouse Analytics Platform. I'll see you all later, and ciao.
Hey, everybody, welcome back. Okay, we have a few questions. I'm going to go through these. So a few of them we've already answered, but I will speak to them. Oh, Reed, did you want to say anything before I answer the question?
No, let's just take some questions for the last 4 minutes here.
Cool, cool. Okay, so first question we have is, do you need to use the web-based editor or can you use VS Code or another IDE? You can edit the code wherever you like. The Dremio web UI is just a nice place to do it, but you don't have to do it there because Dremio, you can send SQL to Dremio either by the Express API through JDBC, ODBC, or Apache Aeroflite. So using any language, you can access those, and most tools oftentimes will connect through one of those levers. So using a tool like DBT, you can orchestrate the whole deal and actually do all that from your favorite IDE, have it in Git version control, and all those benefits. Um, the next question, great, but will the connection from the IDE to Dremio be configured automatically like it was targeting SQL Server? Like right now, there isn't like any built-in integrations for an IDE like Visual Studio, like a Visual Studio extension. But connecting to Dremio is actually pretty easy, and there is a library in the Python Pipo library. So basically, you can easily connect with Apache Aeroflite. But to make it easier, I wrote a little library called Dremio Simple Query, and if you use that, literally within one line of code, you'll be connected to Dremio, whether software or SaaS. And basically, you can actually ask for the results to be returned either as like a pandas or polars data frame, or as an Apache Arrow table, or the DuckDB relation. So whichever way you like to write your local scripts, you literally just send SQL, you get back the package the way you like it, and you just kind of move on doing what you're doing. So that makes it pretty convenient. Next question, thanks. So basically, this is being positioned as a unified analytics alternative to OneLake and Fabric from Microsoft. The way I would put it is that we're solving one of the problems that we solve is a similar problem in the sense of trying to create a unified hub for your data world. A couple differences is that we're cloud agnostic, so you don't have to marry any of the three big cloud vendors in order to be able to use Dremio as your data hub. Also, we have a variety of connectors that can connect you to sources across multiple clouds, and we also have like reflections and the cutting edge data ops features, which are very unique to the Dremio platform. So that makes us sort of very unique in this space.
Yeah, Alex, the other thing I'll add in there is from a TCO basis. When we're talking at the beginning, is we have those differences. Those differences, one of the things that they help us not just on ease of use and helping the customer shift left, which is a big focus. That's how we talk about being a unified lakehouse platform for self-service. It's a big focus for our company, is that all of those things make the organization more efficient. And because we're so focused on performance and price performance, we end up having the lowest cost of ownership of any of the platforms as well. And so we're really coming at it from both angles, which is like the core engineering side to be really efficient there on behalf of our customers. And then also looking at it from the usability standpoint to make sure that the different personas, like the consumers, analysts, for example, and engineers, are both able to be much more productive. When you add those two things together, you're going to get the highest efficiency with a platform like Dremio.
Okay, we got a couple more questions to go. Okay, so the first one, thank you. Reflections effectively materialized views. Quick answer to that is like they're not materialized views in the sense that you're not creating a separate thing that you have to separately manage as a data engineer. That creates a separate namespace that the analyst has to be aware of. Instead, what it is, you're asking Dremio to say, "Hey, I want to optimize this query." It is creating a materialization in the sense of a physical construct. In this case, in the form of an Apache Iceberg table. But Dremio will intelligently identify when to use it. So it won't just use it for that particular view, but it'll also use it for views that are created from that view. So you get more bang for your buck. And on top of it, it's just easier to manage, easier for the analyst to take advantage of.
Yeah,
And for
I
the
mean,
final
can
question,
I add into that one, Alex, which is just look from the query engine has to be able to the big difference is the query engine is able to rewrite the SQL on the fly with reflections. And so if the analyst creates a view and then is putting a Tableau dashboard on that view to run, and they're doing that all self-service, that's great. And normally you might run into some sort of performance issue. In this case, the engineer can go and create a reflection for that dashboard, never even speak to the analyst just to accelerate it. It's totally transparent. And so those groups can go off and move fast, or the engineers can go and say, okay, look, I need to create a reflection here, and the query engine will take care of the rest. That's unique to Dremio.
cool. And one more, and then we'll have to wrap up. But just as a heads up, would be interested in how the cloud agnostic approach compares to OneLake shortcuts that allow the consumption of data across cloud without duplicating the data and data mirroring. Bottom line is a lot of aspects of Dremio's architecture will help you avoid not having to duplicate the data, and also interfaces with many of Azure's tools. So many of the things that you would be sharing the data using one lake within Azure, you can share within Dremio. So you can oftentimes really have that same sort of feel, plus the benefits of the features in the cross cloud features with Dremio. But yeah, with that, I just want to say again, thank you for Reed for coming on to the show this week. Also, come join us again soon. We have some pretty exciting episodes coming up regarding Snowflake TCO and some other really great topics. And then make sure you register for Subsurface May 2nd, May 3rd over there at dremio.com/subsurface. But with that, thank you very much. I'll see you all next time.